name is AHMAD. I'm ZURIMAN. My number matric is AA191485. And for section 3, I will explain about Lab 2 Introduction to Programmable Logic Controller. We will use tool, PLC key, and laptop with logo comfort software. In this lab, video report. Number 1, no written soft copy or hard copy report is required for the lab report. Number 2, the report will be in the form of a video. Duration of the video should be about 15 to 20 minutes. Number 3, compile all the video into a one file and upload it on YouTube and submit the link, or you may also upload the video directly to Utter. Number 4, use your creativity to make the video as informative as possible. Number 5, you must put subtitle to your video. Number 6, submission is 1 week after the lab session. Activity 1, latching. Number 1, develop the ladder diagram in figure 1 like this in logos of comfort software. Number 2, transfer the program to PLC and run the program. Number 3, screenshot the complete ladder diagram. Number 4, record a simple video to explain the operation of the circuit. 3 minutes maximum.
Lab activity 1, latching. In this video, my partner will show about the lab. This is the circuit in the module, and this is our complete circuit ladder diagram. So how this circuit works is when button I1 is pushed, voltage supply will flow to relay contact ML. Relay coil and M1 will produce electromagnetic field and cause contact of M1 to change from open to close. Then the fan will turn on. Then even if we push the button I1 again, the circuit will stay maintain the output energized. So if we want to turn off the fan, we need to operate the I2 button.
Lab activity 2, timer. Task 2A, develop the ladder diagram in figure 2A. In logos of comfort software. Number 2, set the on delay timer to 5 seconds and off delay timer to 10 seconds. Number 3, transfer the program to PLC and run the program. Number 4, screenshot the complete ladder diagram. Number 5, record a simple video to explain the operation of the circuit. 3 minutes maximum.
Lab activity 2, timer. Task 2A. This is the circuit in the module, and this is our complete ladder diagram. So how this circuit works is when button I1 is pushed, voltage supply will flow to both the on delay timer and off delay timer. The on delay timer, which is present at 5 seconds, will cause the normally closed contact to close contact T001 to change state to open, which turn off the bulb, which is Q1 after 5 seconds. Then when I1 is pushed again, it will trigger the off delay timer which is present at 10 seconds, and after 10 seconds the contact T002 will change state to close and turn on the fan which is Q3.
Task would be number 1, develop the ladder diagram in figure 2b in logo comfort software. Number 2, set the on delay timer on 5 seconds. Number 3, transfer the program to PLC and run the program. Number 4, screenshot the complete ladder diagram. Number 5, record simple video to explain the operation of the circuit 3 minutes maximum.
Lab activity 2 timer task will be: this is the circuit in the module and this is our complete ladder diagram. So how this circuit works is when I1 and I2 is connected in parallel, it becomes a OR gate. So when either or both of it is pushed, it will turn on Q1 which is the bull. Then the contact Q1 will change its state from open to close, allow voltage flow to the on delay timer which was present at 5 seconds. Then the contact T001 will allow voltage to flow to Q3 and Q2, which means the buzzer and the fan will turn on.
Last one, lab activity 3, counter, develop the ladder diagram in figure 3 like this in logo comfort software. Number 2, set the counter to 5, double click counter, set the counter as per below like this, on 5 and off 5. Number 3, transfer the program to PLC and run the program. Number 4, screenshot the complete ladder diagram. Number 5, record a simple video to explain the operation of the circuit 3 minutes maximum.
Lab activity 3 counter. So this is the circuit in the module and this is our complete ladder diagram. So how this circuit works is I1 is connected to the reset function in the counter, I2 is connected to the count function, and I3 is connected to the add function, which act like a mode function. Then the counter contact C001 is connected to the buzzer. To trigger the buzzer, simply push the I2 button 5 times because it has been preset at 5.
Sekarang mari kita pergi ke observation untuk lab 2 untuk industrial electronic. Okay, observation yang pertama iaitu state the IP address, subnet mask and gateway for your PLC unit. For the IP address, kita menggunakan 192.168.0.6. Untuk subnet mask pula 255.255.255.0. Dan untuk gateway for PLC kita menggunakan 192.168.0.3. Okey, seterusnya untuk observation yang kedua, state the actual numbers of input and outputs available at the Siemens logo PLC base unit. the actual number of input is 4 and the actual number of output is 3. Okay, the next question is state the address of the input switch. For the input switch, I1, I2, I3 and I4. Okay, next for the observation number 4, state the address of the output lamp, buzzer and fan. Okay, for the lamp, Q1, for the buzzer, Q2, and for the fan, we use Q3. Okay, number 5, how to reset the timer in the lab activity task 2B. To reset the timer in lab activity task 2B, we must pressing the PB1 button which is connected to the reset button on the counter. Okay, next question, how do you set the counter to count up and count down in the lab activity 3? Okay, for the question number 6, we must press the PB3, the push button 3, which is connected to the DIR port. For the next question, the next observation, explain what happens to the output buzzer when the counter counts up more than 5. When the counter count up more than 5, the buzzer remains connected and produce sound. And the last observation, which is the number 8, explain what happens to the output buzzer when the counter counts down less than 5. The buzzer will disconnected and will turn off. Now let's move on to the question in the lab 3. For question number 1, the question is discuss the importance of latching in the ladder diagram. Describe an actual application that implements latching. Okay, as a result, this is an example of latching circuit. The output latch OTL instruction is a retentive output instruction that is used to retain or int an output which is the value of latching in ladder diagram. If this output is switched on, it will remain on even if the status of the output logic that triggered the output become false. The OTL instruction will remain latched on until an unlatched instruction with the same reference tag is energized. The output latches are used to turn in programs that require the output value to remain constant even if the plant is turned off due to power outage. Then there's the program itself, which performs latching. There are times when it is important to keep an output energized even when the input is turned off. A motor that is started by pressing a push button switch is a clear example of such a situation. Despite the fact that the switch contacts are not closed, the motor must continue to operate until a stop push button switch is pressed. The latch circuit is the circuit that performs the sucking process. It is a self-maintaining circuit in that it retains its state after being energized before another input is received. Okay, now let's move on to the question number 2. The question number 2, explain what happens when the inputs are connected in parallel. The input of the circuit will become AND gate. Both of output will start to run at the same time when the current flow through it. Okay, for the question number 3, explain what happens when the output are connected in parallel. Okay, now for the output. For the output, nothing happen at the moment as long as the output at the power supply use the same voltage. Each output will produce same voltage and it is always receive the same input in parallel configuration. For the last question, which is the question number 4, discuss the importance of PLC in industrial application. Nowadays, the PLC scheme is the most widely used in the technology manufacturing field. The PLC programmable logic controller is a device that automates machinery and system operation. It includes three simple features for input, processing, and output, all of which must work in harmony. In order to achieve the desired result or output, the input or data must combine with the appropriate operation or procedure. It's a long and difficult process to automate all of the machines. This development, transportation, manufacturing, this system is responsible for all industrial, manufacturing, and even entertainment development. Transportation, manufacturing of amusement rides, and filmmaking are all impossible without such a device. As a result, PLC systems are extremely essential and required in virtually every industry. I think that's all from me. Thank you very much.